Hi everyone. In this video I am going to explain about CMOS inverter and followed by 2 input NOR gate. So first CMOS inverter. In the previous video I explained about the devices like a PMOS transistor, NMOS transistor and their operation. So with the help of PMOS and NMOS transistor we are going to design a CMOS inverter. CMOS stands for complementary. C stands for complementary metal oxide. Complementary metal oxide semiconductor. So in the complementary metal oxide semiconductor design, the output is a complemented version of the combination of inputs. Output is a complement of the present combination of the inputs. So most commonly CMOS devices like transistors are used for the designing of any digital circuit. Okay, so the first and foremost CMOS logic circuit is a CMOS inverter. So the basic element of CMOS digital circuits is CMOS inverter. So CMOS inverter, remember CMOS is not a transistor. CMOS is not a transistor because the CMOS consists of PMOS plus NMOS devices. PMOS alone is a transistor, NMOS alone is a transistor, but when we combine PMOS and NMOS transistors, then we can form a structure called CMOS structure. Okay, so when a PMOS transistor and an NMOS transistor are combined together, the resultant structure forms a CMOS structure. Okay, but CMOS is not a transistor, remember that. Okay, most commonly we use CMOS transistor, but it is not a transistor. It is a combination of two transistors, PMOS and NMOS transistors. Okay, now how to interconnect these two? How to interconnect this PMOS transistor and NMOS transistor? So CMOS inverter, as I said, it consists of one PMOS transistor and one NMOS transistor. So PMOS transistor, NMOS transistor, and the inputs for these two is commonly applied. Suppose if it is a single input, then we have taken the common terminal and applied A. And if it is consisting of two inputs, then A is one input, another one is the B is the another input, which is again commonly applied to both the transistors. And output we are taking from drains of these two transistors, which is taken from these two. This is the output terminal. And PMOS transistor set is connected to VDD and NMOS transistor other terminal is connected to ground. Okay, very important. PMOS device or PMOS transistor is connected between VDD and output. PMOS transistor is a pull-up device. It is also known as a pull-up device. So PMOS transistor is a pull-up device which is connected always between VDD and output. And NMOS transistor is connected between output and ground. NMOS transistor devices, see, if it is one transistor is connected between output and ground. If it is having two or more, then also they should be connected between output and ground. And this device is known as pull down transistor or pull down device. So PMOS transistor is a pull up device, NMOS transistor is a pull down device. Okay, pull down means whenever this transistor is in on state, the output goes to 0. And PMOS, why it is pull up? When this device is in on state, the output goes to logic 1. So output pulls to up state and output pulls to down state because of these two transistors, PMOS and NMOS respectively. Okay, now let us see the CMOS inverter with Y is equal to output Y is equal to complement of the input A bar. So as I said, one PMOS transistor we are taking. Okay, here we can consider any type of symbolic representation. As I said in the previous video, there are three different representations. Out of these three, you can take any of these, and this is connected to VDD. So PMOS representation with a bubble and NMOS no bubble, and these two are connected. This is the input. So input we are taking A, and output is always taking from drains of these two terminals, these two transistors, which is equal to A bar. So this is a PMOS transistor and this is NMOS transistor. This is source terminal, NMOS transistor source terminal. Okay, as it is the beginning circuit, I am representing the arrow also for your convenience, so that you can understand which is source terminal and which is drain terminal. Actually, in the MOS technology, there is no specific representation of source and drain. You can use in any of these terminals. You can use this terminal as source or this terminal as a source. Okay, it is a bidirectional device. Okay, and here in the PMOS transistor, this is the source terminal and this is the drain terminal. This is the drain terminal. As I said, this is source, this is gate, and this is source. So sources of these two are connected to power supply rails, VDD and ground, and drains of these two are connected to output terminal, Y is equal to A bar. So what happens when input A is equal to 0? When input A is equal to 0, PMOS transistor is in, what happens? So this 0 is applied to both PMOS and as well as this 0 is applied to NMOS. So PMOS transistor comes into on state and NMOS transistor comes into off state. I already told you when the transistor comes into on and off. Okay, so PMOS comes into on state. As it is in on state, there is a short circuit path. There is a short circuit path existed between VDD and output. So simply Y is equal to 1. Y is equal to 1. But what about when A is equal to 1? When A is equal to 1, PMOS transistor, what happens? PMOS takes 1 goes into the bubble, so it becomes 0 and makes the transistor off. So PMOS transistor off and NMOS transistor on. NMOS transistor on. So Y is equal to simply 0 because NMOS transistor is in on state. That makes the output to discharge. Okay, generally we will consider a capacitor here. It is known as a load capacitor. When you are working with digital circuits and their analysis, we generally consider a load capacitive load at the output to calculate the rising and falling periods, and as well as when you are connecting the output of any circuit to other circuits, this acts as a load. Okay, so during rising period, that means when input is equal to 0, when PMOS transistor is in on state, there is a static current flow from VDD towards this capacitor. So the capacitor charges like this. This is the charging period of the capacitor. Capacitor charges and goes up to VDD. But when capacitor discharges, that means when the input is equal to 1, then what happens? Capacitor NMOS transistor comes into on state and the capacitor previously accumulated charge has been discharged through the NMOS transistor. Okay, discharge means output is equal to 0. So whenever we are giving 0, output is 1. Whenever we are giving 1, output is equal to 0. So there is a complemented version of the input to output. This is CMOS inverter. And coming to CMOS 2 input NOR gate. CMOS 2 input NOR gate. See, basically in the digital circuit design, digital electronics, the basic elements are AND OR inverter. We know very well, AND OR inverter. And in NAND gate, NOR gates are the universal gates. But whereas in the CMOS technology, the first and foremost gates inverter, followed by NAND NOR, because NAND NOR gives you the complemented version, as the CMOS also gives you the complemented version. Just by designing the two input circuit, we will get the NOR or NAND, depends upon the parallel or serial connections. Okay, so take y is equal to, NOR means a plus b bar, a plus b bar. Here remember one thing, when it is a plus combination, you have to connect, see, for plus realization, PMOS transistors, for plus realization, CMOS transistors should be connected in series. Okay, for plus realization, PMOS transistors should be connected in series. For plus realization, NMOS transistors should be connected in parallel. NMOS transistors should be connected in parallel. Another thing is, opposite is the case with other devices. For product means a plus a into b whole bar. For product realization, PMOS transistor connected in parallel. How many transistors we have? That many inputs we have. And product NMOS series. Okay, like this. Plus PMOS transistors in series, product NMOS transistors in series. Okay, now the realization is plus. So plus means, and one more thing, how many transistors we need? See, how many number of inputs is equal to number of PMOS transistors, that is equal to number of NMOS transistors. So in our design we have 2 input NOR gate, so here we need 2 PMOS transistors and 2 NMOS transistors. Okay, how to connect these 2 PMOS transistors and these 2 NMOS transistors already I have given here, this one and this one. Okay, and another thing, PMOS transistor should be connected between VDD and output, NMOS transistor should be connected between output and ground. Okay, keep all these points in mind when you are designing a CMOS digital circuit. So PMOS transistors for plus, how they will be? In series. So here they should be connected in series. Next, NMOS transistors should be connected in parallel, and NMOS transistors are connected in parallel, plus VDD, and this is output is nothing but Y. Okay, so PMOS, and this is PMOS transistor A, B, this is NMOS A, and here it is NMOS B transistor. Okay, so PMOS transistors should be connected always between VDD and output, and NMOS transistor should be connected between output and ground. Okay, now here the thing is, when inputs are applied A and B, depends on that the output realization like A plus B bar will be evaluated. Okay, this is circuit known as, the circuit is known as CMOS 2 input NOR gate. Okay, thank you.